I'm going to be showing you how to connect a push button to a Raspberry Pi and control a Python turtle with it. Now, you may or may not be familiar with the Python turtle package. It basically lets you draw on the screen using various commands. You basically move a cursor around the screen as it draws a line behind it, kind of like an Etch-a-Sketch. So the first thing we need to do is connect the hardware. So you can see in my webcam view here the setup that I currently have. I'm following this circuit diagram here, which shows how to connect a push button to the Raspberry Pi. Here is the power source, in our case 3.3 volts. Here is the push button switch, and here is a pull down resistor. This GPIO in line is the line that gets connected to our Raspberry Pi's GPIO input. Let's go back to the webcam and I'll point out the different parts. So this here is our push button. It's connected, one side of the push button is connected to power, the red wire, and the other side of the push button is connected to our Raspberry Pi's GPIO input, 26, as you can see right here. The GPIO 26 pin is connected through a 10 kilo ohm resistor to the ground of the Raspberry Pi right here. These three connections, along with the resistor, are required to connect a push button to the Raspberry Pi. Be sure that you don't forget the resistor, or that you don't use a resistor that's too low of a resistance, or you will fry your Raspberry Pi when you push the button, because you'll be connecting power directly to ground. So that's all we need for the hardware. We'll now switch over to our Raspberry Pi and write some code in Python to control the turtle using this push button. So in your Raspberry Pi, open up a terminal and use your favorite text editor to write this code. I'm going to use VI because that is the text editor I'm most familiar with, but you can use Nano or gedit as well. So I'm going to open a new file by typing VI turtle button.py, .py denoting a Python file. This gives me a brand new file where I can begin to type. I'm going to type import rpi.gpio as GPIO. This tells Python that we want to use the GPIO pins on the Raspberry Pi and gives us access to pre-written functions that somebody else has written to interface with the GPIO pins. I'm going to import the time module as well, telling Python that we are going to want to use commands from the time module later, and you'll see later how we do this. And we want to control a turtle, so we need to import the turtle module as well. If we look at a GPIO pinout diagram for the Raspberry Pi, as I see here, there's two main ways to number the pins on the Raspberry Pi. You can either reference the pin number, which just starts at 1 and goes 1, 2, 3, 4, 5, 6, etc., all the way down to 40. as labeled here. This is the pin number. But there's also a way to number the Raspberry Pi pins using GPIO numbers. So in this case, pin 3 is GPIO 2. Pin 5 is GPIO 3. We've connected the push button to pin 37, which is GPIO 26. So I'm going to use the GPIO numbering convention, also known as the BCM numbering convention, which means we have to use these numbers here, 26, 19, 13, 6, 5, etc., if we want to reference these pins. So going back to my Python file, I'm going to tell Python that I'm using the GPIO numbering convention by typing gpio.setMode gpio.bcm. We want to set up pin 26 as an input. So to do that, I'll type gpio.setup and pass it two arguments. The first is the pin number, in this case 26. And the second argument tells it that we want it to be set up as an input. We want to be able to read the value of this pin. So that's all the setup we need. We can now start our turtle and start controlling it with the push button. In order to do this, we need a loop, because we need to continually move our turtle around. And when the button is pressed, I'm going to have the turtle turn. So I'm going to set up a loop for I. I'm actually going to do this differently. I'm going to say while 1 equals 1. Note the double equal sign. So this says while the number 1 is equal to the number 1, we're going to continually loop over the following indented code. As you know, 1 is always going to be equal to 1. So this will create an endless loop that will continually move our turtle around. At the start of the loop, we're going to move our turtle forward. So every time through this loop, the turtle is going to move forward. To do that, we type turtle.forward, and I'll move it forward 4 units on the screen. After the turtle has moved forward, we want to check to see if the button is pressed. If the button is pressed, we want our turtle to turn slightly. To do this, we'll use an if statement. If GPIO input 26, so this says read the GPIO input on pin 26. And if this is equal to 1, meaning the button is pressed, then we want to move our turtle to the right 12 degrees. Or 12 units. Notice how I've indented this line. This means that the turtle.right will only be executed if the button is pressed. And finally, I'm going to go back out to the while loop level and type time.sleep 0.1. This tells Python to wait 1/10 of a second, or 0.1 seconds, before continuing to the next iteration of the loop. And that's all we need. I'm going to save the file and close it. And I can run it by typing Python turtle_button.py. You'll see a turtle appear on the screen and keep moving to the right until I press the button. I'm going to press the button in 3, 2, 1. You can now see the turtle is moving. And I can keep pushing the button and having the turtle move around. If I don't push the button, the turtle moves in a straight line. If I push the button, the turtle curves. And that's how to control a turtle with a push button. Using the Raspberry Pi's many GPIO inputs, you could create a multi-button turtle. You could control the turtle using 4 buttons, for example, left, right, up, and down, using the same concepts and very similar code that we used here. Thanks for watching.